Okay.
If you have been joining the session, let me know, okay? And just let them answer the Zoom session. Okay. Okay, question 1. I don't know if any of you remember this question because I don't at all. And I was struggling to recall and understand this paper as well just now. Okay, so just to quickly recap, what you guys did here was FB1, which is a carbonate. Sorry, no. FB1, which is a carbonate, reacting with hydrochloric acid. Yes? And that is our first reaction. FB1 reacting with hydrochloric acid, and if you react the hydrochloric acid with a carbonate, you would expect to form salt, carbon dioxide, and water. Yes? And then the hydrochloric acid is in excess. You will then titrate the remaining acid. So the remaining acid means the unreacted acid from reaction 1 will then be titrated with sodium hydroxide. So this is the second reaction. Okay? So if I were to write it down here, the first reaction is sodium carbonate, which is my FP1. I can't stop here. Okay, please let me enjoy the session. Okay, thank you. All right, so that's how it's going to be nowadays, like that. Okay, I have my Zoom session on and also choose to be class. Okay, back to this just now. So FB1 will react with my HCl, which is FB2. And the question already said that FB2 is in excess. Okay? And then any remaining HCl, whatever that is not reacted from this equation, will then be titrated with sodium hydroxide. The reason why we want to titrate our unreacted HCl is that if we know the number of moles of our sodium hydroxide, we can find the number of moles of our HCl. Okay? And why do we want to find the number of moles that was left unreacted? Because if we know initial, and then we know if we know the initial number of moles of HCl, the one that we started with, and we know the number of moles of HCl remaining or unreacted, we can actually find the number of moles of HCl reacted. Okay? All right, so if you look at the question, okay, and then you do your titration as usual, and then you find out the volume of FP3, and if you notice here, FP3 is your sodium hydroxide, which you know the volume of your titer, okay, and you know the concentration. So that means volume of titer times concentration, you can find the number of moles of sodium hydroxide. Right? Let's have a look at the questions. Calculate the number of moles of sodium hydroxide present in the volume of FP3 calculated. So this is where you find the number of moles of sodium hydroxide of your titer value. Okay? Which is I don't know, how come I get this number? Maybe I think I use 10 as my volume. Okay? So after I know the number of moles of sodium hydroxide, this number of moles of sodium hydroxide neutralizes the remaining hydrochloric acid. Reduce the number of moles of remaining hydrochloric acid. Okay, so if you look here, once I know the number of moles of my sodium hydroxide, I can then find the number of moles of HCl, which is 1, 2, 1. Okay? And this HCl is the unreacted or the remaining HCl from reaction number 1. Okay? Calculate the initial number of moles of hydrochloric acid in each 25 centimeter cube of sample of FB2. When we go to the first part, FB2, we know the concentration, and we also know the volume of FB2 being used, which is 25 centimeter cube. This is the initial number of moles of HCl, because this is what we started our HCl with. Okay? So far we know initial, we know remaining. That means we can find the one that actually reacted. How much of the Fe2 actually reacted with the sodium carbonate? Okay? So I will just zoom this out. If you follow my working, this is my first reaction. Okay, I started with some amount of sodium carbonate. I started with an excess, with a lot of HCl. Some of my HCl would have reacted with sodium carbonate. Some of them remains unreacted. To find how much is unreacted, actually I'm only interested how much has reacted with sodium carbonate, but in order to find that value, I need to know how much is left. Okay? Once I know how much is left from here, I can then now on to part 3 of my working. Okay? Part 3 is to find the initial number of moles of HCl, which is what I started with initially. Okay? And then to find the number of moles of HCl that has reacted, I take initial minus remaining. Okay? And lastly, I believe the question will ask me to find the number of moles of the sodium carbonate FB1. Okay? To find FB1, once I know how much HCl has reacted, it has a 1:2 ratio. Okay, so once I know the HCl here, I can find the sodium carbonate number of moles of sodium carbonate. Okay, so that's a lot. I will let you. I don't know if you want to copy this or you want to jump straight to the questions. What do you think? You want to copy this down? Yes, or you prefer to just do everything here? Jump sini colors. Okay, but I'll leave it here, and then later on, for those of you who want to copy my working, I can show it to you. All right? Okay. So this part is where we find the number of HCl that actually reacted. Okay. And lastly, you have to balance the equation, which I have done in the first part already just now, because I feel like it's easier for me to understand and to do my calculation if I know what's happening. Okay? If you follow the question, then you know that this equation is actually reaction number 1, according to my working. So this reaction happens first, and then only the neutralization reaction or the titration reaction. Okay? So you should get a nice number of x, because x should be a whole number. Let me just have this for you side by side. So, okay, so I'll leave that for you for now. If you want to copy down the working, you can. Not sure if you can see it though. That's the best I can do. And I'm gonna see. Okay, never mind. I will give you this working first for page 3 and page 4. Okay? And then I'll move on to my working. But that one is small. Is this okay? Hello. Okay. I'll just move to one page first. Sorry? It's all? Yes, this is all in one drive, on one drive. It will be oh yeah, if you don't get to copy the working, my working, you can always refer to the document in one drive itself, okay? Is there any question? No. So you're okay, you can follow what's happening for this question one, okay? Part 5. So once you know the number of moles of sodium carbonate, you will then find the MR. Okay, part 5 is worth mentioning because this is a formula that students always tend to forget. Okay, so if you know the concentration in grams per dm cube, which I believe is being given to you already in the first part of the question, where we know the concentration of sodium carbonate is 37.5 grams per dm cube. Using the calculation, you can also find the concentration of sodium carbonate in mole per dm cube. Okay, so if you know the concentration in grams per dm cube, and you can find the concentration of mole per dm cube, there is a formula that you can use that includes the MR term. Okay, if you take your concentration of grams per dm cube divided by the MR, you see here grams is mass over MR, you get mole. Okay, so then rearranging this will give you the MR of the sodium carbonate with XH2O. So once you know the MR of that formula, you can then work out, add up each individual AR values, okay? And 2 times the AR of sodium plus AR of carbon plus 3 times the AR of oxygen and plus X times of the MR of water, which is 18. You can work out what X is, and X should be a nice whole number. Okay. I don't know if X is 5. I think X is 10, if I'm not mistaken. But your volume was a bit odd, right? Last time I remember it was like around 10, 9 centimeters. I think there's something wrong with the dilution when the lab technician prepared the solution. Okay, because usually it wouldn't be that small. So that means we are saying actually was in school yesterday. Did you finish that self-ISO? Yeah, and then it was something well. Ayman. Start talking to myself. Right? Ayman, are you there?
Yeah.
Are you on self-isolation? Quarantine order?
Not really. Macam, yeah, I just don't feel well.
You don't feel well.
Okay.
Are you a close contact of anyone you know positive?
Yeah.
Huh? You know someone who's positive?
Yeah.
In your house?
No.
Your friend?
In school.
In school?
Yeah.
How long has it been?
I already art test like for first day and fifth day,
So when's your
both
fifth
negative.
day?
Today,
Today. Tapi you're not feeling well.
yeah,
Okay, then do another one later tonight. So you're expecting to come back to school tomorrow lah.
yeah,
Okay, so do one later tonight or tomorrow morning. And then if you're okay, then you can come to school. But if you're still not feeling well, then you don't have to come tomorrow, okay?
okay,
Yeah, so you just update me in the group or you private text me, okay?
okay,
Okay, yes, I need to send you the text to remind you to do your art test tomorrow or later tonight, okay? If you're not feeling well, and especially if you know that you are in close contact of someone, please don't come tomorrow, okay? Because you will mix with, I mean, in one lab, I think, I don't, you will be with other, from other classes, okay? So that's why we don't want, anything to happen. At least if anything happens to us, it will just be us in this class. Okay, yes, then? No, you will stay on the table. Everything will be given to you in front of you. Station, there's no station for chemistry. So you should have everything in front of you already, and there will be the mass balance will be shared. In which case, when it's available, then you can come to the front. It will either be in front of you or behind you. So just make sure to have a look around you before the start of the exam. You want to find the nearest mass balance. So students usually they will come all the way from the back to the front, but there's actually a mass balance behind them, much closer. Okay, so you don't have to change station. You will stay at your seated at your bench or your workspace for the whole 2 hours. Okay. Now, if I can remember, and if I'm not mistaken, there will not be a citation question. Okay. So if you think that you can score from citation questions, then that's not the case. Okay, if I remember correctly. But if you see a citation question tomorrow, you do it afterwards. Okay. That's all I can remember. And if I'm not mistaken, there are only 2 questions. So you can imagine the qualitative analysis question is going to be a long one. A long one means difficult to see. Okay. So question 1 is not a titration question. So please have a look at the other type of practical like heating, temperature. 2. That's what I said. The qualitative analysis will be a long question. Since you only, yes, I have, but I don't remember. I don't remember like. I don't remember. But I can tell you there's no migration. Okay. Now, so my tip for you is to collect the data, collect the results. Per question, 30 minutes. If you can do it shorter, then that's better. Okay. So you have 1 hour to work on the questions, calculations. If there's a graph plotting, plot your graph. What else do you usually have? Yeah. So things like table, don't forget your units, don't forget your decimal places. If there's graph plotting, don't forget your axis. If there's no graph plotting, that means your calculation, you have to be careful. Rulers, just in case you need them. Calculator is important. Please do not leave your calculator. I only have one to lend you. I took one if you tell me early in the morning, I will be already busy by then. What else is important? Qualitative analysis, I'll talk about that later on when we look at the notes, okay? Now, next one. Adalah, there will be calculation. There's no calculation, yeah. I mean, you look at question 2, there's no calculation, right? Heating, there's calculation. Temperature, there's calculation. Rate of reaction, there's calculation as well. So it would be one of those. And I'm recording myself, so if anyone else watches this recording, then they say, oh, discovering it as no, but I really don't remember the question. That's all. That's all I can remember, that there's no such thing. Okay. The next part. Did you all manage to get X? Is anyone working on their X right now, or they're just going 3.8? So X equals to 4. Now, anyone else? Anyone with a different answer? 3.4. So 3.4, you can make it as a 3 or as a 4. Well, I would be closer to make it as a 3. Okay. Any other different number for X? No. Okay. Right. A student suggested a different method. To 250 centimeter cube of Fp2 and 10 centimeter cube of Fp1. I prepared 25 centimeter cube. After this mixture of solution is Fp3, repeat hydration. Okay, so what's the difference here? Di sini. Okay, here the difference is that you take out 25 centimeter cube of Fp2 and 10 centimeter cube of Fp1 for every titration. Okay, so you repeat 25 and 10. In the question, they want to mix 250 and 10 centimeter cube initially, okay, before you start titration. And then for each titration, you will then only take 35 centimeter cube. Get what I mean? Or method B, we mix 250 of Fp2 plus 10 centimeter cube, 100 centimeter cube of Fp1. Okay, and then for each titration 1, and this one is mixed into one big beaker. Okay, and then for titration 1, I just take 35 centimeter cube, and then titration 2, I take another 35 centimeter cube. You see the difference? Whereas method A, I use 25 centimeter cube of Fp2, 10 centimeter cube of Fp1, and then I titrate. Okay, titration 1. Titration 2, I take a new fresh sample of 25 centimeter cube of Fp2, and then 10 centimeter cube of Fp1, and then I do titration number 2. So you can see, guys, here I individually measure out the required volume, but in total, you see 25 plus 10 is 25. Okay. As for method B, I mix everything, make my life easier. Mix everything and just take out 25 centimeter cube and then carry out titration. Okay. So the question is now, what's the question? Which one is better? Is it? One advantage or one disadvantage? One advantage and one disadvantage of this method. Okay. So the first, let's talk about the disadvantage first. Okay. What is the disadvantage of doing method 2? If you contaminate this solution, this mixture, that means all the titration 1, titration 2, titration 3 will be affected. So that's one of the disadvantages, right? The advantage, because we are using a bigger volume, of course, we don't say advantage because it's easier for us, right? That's not an advantage. When you carry out a practical, just because it's convenient for us, it's not an advantage. Because sometimes, even though it's convenient, it doesn't mean that it's more accurate. Okay? So we're not going for convenience here. The advantage of this is that because we are using bigger volumes, the percentage error is smaller. Okay? So percentage error is usually taken as the error, the smallest error per apparatus over the value that we use. I go back. Okay. Percentage error is equals to error over volume. So you imagine if your volume is bigger, instead of using 10 centimeter cube, we use 100 centimeter cube. What happens to your percentage error? It's smaller. Okay? So that's why actually in any practical or in any reaction, if you use a bigger value, whether it's a bigger volume, bigger mass, your error will be smaller. Then you may ask, so why don't we do it? Because it's just not economical. Okay? That's why for your case, in just like a normal lab, in a school setup, we can use small values because we're not really after accuracy. Okay? And the error, well, there will be bound to be error. But if this was an industrial, commercial purposes, of course, they will use big volumes because the error is also decreased or reduced. Okay? So this percentage error, you need to learn the formula or how to calculate. The error is usually associated with the half of the smallest reading of your apparatus. Okay? Apparently, there is one note that I never get to. I don't know if I ever gave this to you. Do you remember seeing this note? Have I given this to you before? It's called practical skills. Ada. Oh, you haven't thought you didn't receive it. So anyway, but if you cannot find it, I will upload them on OneDrive as well. Okay. So it's worth reading. Just have a quick read. Do not memorize them. Okay. Of course, if you go to qualitative analysis, there will be one whole page of the instructions to test for the ions. You don't have to memorize it because you have access to the qualitative analysis notes. Oh, it's actually 2 pages. 3 full pages of text and just instructions to test for your qualitative analysis notes, which you do not have to learn because they are all given to you here. Okay? Right, let's move on to question 2, otherwise we will not have enough time to do this. Okay, so I will just so for question 2, what we did was we heated some solid at before. Okay, usually when heating a solid, you would expect the mass of the solid to increase. Yes, correct. That means when I heat my F34 will turn into what we call a residue, which is a solid, and there will be also some gas escaping. Okay, in this case, the gas is H2O gas. So that's why you expect some mass to be lost because of the H2O gas that has been lost in this reaction. Now, when you are given solid to be heated, please highlight all these words like weigh, reweigh, calculate. That means these are the things that they want you to include in a table. Okay? So you should have these 6 entries in your table. The mass of just the crucible, the mass of the crucible plus Fe4, the mass of crucible plus residue. Residue is the solid that you are left with after heating, okay? We don't call it Fe4 anymore because it's no longer an Fe4. It's no longer MsO4 with 7H2O. Okay, it is now a different solid, but related to the starting material. To find the mass of Fe4, you have to take 2 minus 1. Okay, so these are some of the things that some students still struggle to calculate. Okay, mass of residue is the mass of the solid that you want to know that's left in the crucible. So you take 3 minus 1. Okay, and the mass of water loss is your Fe4 minus your residue. Okay, the solid after. So, for example, I started with 5 grams, right? And then my residue is 4.5 grams. That means the 0.5 grams must have been the water that I have lost. The gas, sorry, not the water. The gas that I have lost. This is applicable to other solids as well. Okay? When heating a solid, we should expect the mass to decrease. We don't heat solid for fun. At least not for question 2. For question 3, sometimes we heat solid because we want to look at the observation, what happens in the solid, the color, does it dissolve, does it disappear, does it melt? Okay. Right, to calculate the number of moles of water loss, in fact, you have to take the mass loss and divide by the MR of H2O. So that is your mass over MR calculation. The MR that you use here is 18. Now I don't know what sort of number you got for your mass loss. Can you share? 0.7. Anyone got that? 1? 1. Okay. So use your whatever your number is. Okay. X. So it will be different for everyone, right? Because you would have started with different mass. Sometimes things like you may have dropped some of the mass during transfer. Many factors. Okay. Okay. So once you find that moles of water, you are then asked to write down the equation. Okay, so this is the sort of things that they can ask you. Okay, do you need to revise your theory? A little bit, yes, especially things like, I don't know, reaction. It's so hard to say because if your qualitative analysis is on organic chemistry, you need to have a little bit of organic chemistry knowledge. If it's on inorganic chemistry, that means your topic 9, periodic table, some of those information will be needed, especially group 2 carbonates and group 2 nitrates compositions. When you heat them up, if you see a brown colored gas, what is that? That should have come, that means it can come from a nitrate, group 2 nitrate. If you see a carbon dioxide, when you heat the solid, that should have come from carbonate. Okay? So things like these are the ones that really difficult to target now. Okay, it's not, you cannot target what will come out and the sort of question that they will ask you. But calculation, definitely you have to learn. All the past practical papers that you have done, go through them, try the calculation. If you don't understand the working from the mark scheme, you can always refer to the working that I have in OneDrive. Okay, those are the ones that we have discussed in class. What are the possible things that can come out? Writing down balance equation. Things like solidity rules will also come into play, especially if they want you to write down the state symbols. Okay, otherwise you just have to try your luck. Things like, I don't know, zinc sulfate. Is it aqueous or is it a solid? Things like that. Okay. Okay. Once you have written down the correct and the balanced equation for this reaction, you know the number of moles of H2O, correct? From the first part of the calculation. They then want you to find the number of moles of the MSO4. Can you see that this is actually a field? Deduce the number of moles of anhydrous salt MSO4 left after heating. That means the residue is MSO4. Okay? So actually sometimes reading the question can give you a little bit of hint. So kiranya, if you didn't know what are the products. Okay, so you read the question, it says that you have metal sulfate left, and the only thing that you have left is the residue. So if you know the number of moles of H2O, you can find the number of moles of MSO4, okay, which is your residue. Okay, and this is the residue. Okay, any questions so far? Can we move on? You then are required to find the MR of MSO47H2O. Now this is FB4. FB4 is not the same as residue. Well, strictly speaking, they're not the same. But numerically, they are the same because 1:1 ratio. Okay? The number of mole is the same, but the mass will not be the same. Okay? Okay, so once you know the number of moles of the you know the number of moles of MSO4, which is the residue from this part 2. Part 3, they want you to find the MR of FP4. But before you know the MR of FP4, you must know the number of moles of FP4 first. Okay? In this case, number of moles of residue is equal to the number of moles of FP4. I will erase this because otherwise it will be. Okay? But my point is residue and FP4 are not the same chemical. Okay? And then if you want to find the FR, is the normal mole calculation mass over number of moles. Once you find the FR, you can then work out the AR of M. Same thing, you add up the AR of M, which is, I don't know, our X, add up plus the AR of sulfur, 32.1, plus 4 times of oxygen, 4 times 16, plus 7 times of H2O, which is 7 times 18. It gives you whatever the number you have from part 2. Okay? And when you find the AR of M, you will choose a metal that is closest to the AR, but not just any metal. It has to be a group 2 metal. So read again the question. Okay, so you don't just simply choose, oh, whatever the metal is, it has to be in group 2, according to the question. Everyone okay? Following? Okay. Next one. In the method used above, the lid was placed on the crucible when the crucible was left to cool. Okay, so after heating, I don't remember what we did. Heating without the lid to go, and then place the lid. Okay, right. So during heating, you open the lid, you let the gas escape. Then you let the H2O escape. When cooling, then we close it. Okay, so students always think that, oh, if we close something, that means we don't want anything to escape from it. Yeah? If you put on the lid on something, this is because we want to avoid the gas to escape. But in this case, we want the H2O to escape, which we have done that during the heating. Okay, during heating we open, right? We let it escape already. So the reason for putting on the lid during cooling is not because we don't want H2O to escape, but instead we do not want water vapor from the environment to come in contact with our residue. Okay, so that's why we put a lid onto it. The reason for that is if we have H2O vapor, not this one already escaped. Okay, if we have vapor from the environment, from the surrounding, making a contact with the residue, then this mass would go up. Agree? So that means we have overestimated our mass of residue. Okay? So that means it's not accurate. We want to take the mass of the residue, just the residue alone, not when water comes in contact with it. Okay? Right. So that's the first reason. Well, that's the only reason why we put on the lid during cooling. Okay? Sabi mo tayo ko. Which is around 40 minutes now. Suggest and explain the effect on the calculated value. So they want us to comment on what happens to our FR value based on the calculation when the lid is off. Okay? Okay, this one is a little bit, the first part is a little bit confusing. Right. So I'm going to use these numbers are just some made up numbers. Okay. So with lid off, which is the procedure, normal procedure, I started with 5 grams, 4.5 grams residue and 0.5 as my water vapor that has escaped. Okay. If I go Sana, this is lid on, which is the normal procedure. Lid off, say I use the same mass, okay, and then now that there's no lid, and now that I have water coming in contact with my residue will become heavier. The mass will become heavier. Say 4.7 grams, for example, just to make up number. Okay. So how much mass calculated is the mass loss of water based on the total mass must be the same as what I started with. Okay, so that means my mass of water loss is now 0.3 grams. Okay, actually, sebenarnya it's not 0.3, but because I cannot say it's 0.5, otherwise that would be over 5 grams. Okay, it's much more than what I started with. Okay, so calculated is 0.3. The effect here is that the mass loss is now underestimated. Okay, mass loss of H2O is underestimated. the mass of residue is now overestimated. It makes sense. Okay? Now we want to know what's the effect. If the mass loss of water is underestimated, which is lower, the number of H2O will also be, number of moles of H2O will also be lower. Okay? Then listen, the step mental. The number of moles of H2O will also be lower. And then if my number of moles of H2O is low, number of moles of my metal sulfate, which is residue, will also be low. Okay? Are we okay so far? Yes. If my number of moles of MF4 are low, number of moles of FB4 will also be low. Number of moles of FB4 is low, what happens to my MR? MR goes up. So this is how we work out the effect of whatever onto the calculated value. You have to go through each step. Okay? So that's why for one mark column actually, but the explanation is done. Okay? So the mass of water loss will be less, or the word that I use is now underestimated, which will result in the number of moles of H2O to increase, number of moles of FB4 to increase, and your MR to increase. We just want to know the effect. But if you think that you do not have time to do this, to go through all this thinking, with one mark, I say you have a 50% chance of getting it right. Either you say your MR will increase or your MR will decrease. Okay? But of course, sometimes we want explanation as well. Is that okay? It's a little bit difficult to understand. For me, it took me a while to understand why the mass of water will be less. Okay? Because you leave the lid on. You would expect a lot of water to escape, right? But that's not our problem. The problem is that when you leave the lid on, you're exposing the residue. It will come in contact with water. So this makes the residue heavier. Okay? But because in our calculation, we don't use the mass of residue at all, if you notice. We don't use mass of residue. We only find the number of moles of residue based on the mass of water. That's why I have decided to comment on the mass loss instead of the mass of residue. Okay. Right. Do you want to move on? Okay, you can copy down the answer later from OneDrive. Okay, so for 3.A1, this is ammonium vanillate. Basically, they just want you to write down the observation. Okay, they don't need you to deduce, or I don't think they want you to deduce. And that, okay? So they just want you to record all the observations. You don't have to identify what this reaction is doing. So you should have seen the yellow solution turn blue or green and then purple. Okay, I don't like to use the word like that. All right, part 2, and this is also something that I want to remind you. When you use potassium manganate, say you have a test tube of a solution that is colorless. You add potassium manganate. It turns purple, right? That is not a change. That is the original color of potassium manganate. Of course, your colorless solution, when you add a potassium manganate, it turns purple. Of course, it turns purple. Okay? But if you were to write down this observation, do not say the colorless solution turns purple, because that's not a change. If you say potassium manganate stays purple, then that's correct. Okay? The solution is meant to turn purple because potassium manganate is purple originally. Okay? If you see the potassium manganate in the purple color turning colorless, that is an observation. Okay? Purple decolorizes or purple turns colorless, which is the expected observation that we have here. Now, purple color of the potassium manganate is actually due to the MnO4 minus ion, the manganate ion. Okay, and the colorless solution is actually of Mn2 plus. A lot of students think that Mn2 plus has color. Mn2 plus doesn't have color; it is colorless. And the purple color is usually associated with the MnO4 minus. Okay, this is due to the different oxidation number. Okay, so the type of reaction is a redox reaction because this one is -1 plus 8 plus 7 to go to +2. Manganese is being reduced from +7 to +2. Hence, we call it a redox reaction. +7 plus. Okay, next is 1 centimeter depth of dilute sulfuric acid at a small spatula measure of 55. Okay, we got your observation. Okay, now when you add acid, if you know that it is acid, you add it to something, you are all familiar with acid-base reaction, acid reaction. Acid reacts with base, you form salt and water, no observation. Acid with metal, you form salt and hydrogen gas. Hydrogen gas is an observation. Another reaction is acid plus carbonate. You should get salt, carbon dioxide, and water. So you can observe carbon dioxide. So when you're adding acid, in this case, you're being told that you add sulfuric acid. The gases that you want to try is hydrogen gas or carbon dioxide. Okay? Do not try to attempt all the gas tests here. Every time you say effervescence, you can have ammonia, and then carbon dioxide, then chlorine, then hydrogen, and then oxygen. You sort of have to think about that reaction. Okay? Because if you do that, you do all this, one, it will be time consuming. It is not worth it. Okay? For 1 mark, yes. It is not worth it to go through all the tests for the gas just to do what? Just to get 1 mark. Okay? So that's why you have to be smart when before you carry out the steps, you think, oh, I will be adding acid onto something. I don't know what that thing is, but if I see effervescence, there are 2 possibilities. Okay? Hydrogen gas or carbon dioxide gas. If you see hydrogen peroxide, H2O2, possible gas would be oxygen. Okay? FP6, FP5. Okay, so FP6 is the active solution that has been made by reacting FP5 with dilute sulfuric acid. Now, I don't know if you managed to observe this. There should have been a pop sound. Okay, so that means it's hydrogen, which suggests my FP5 is a metal. Okay, so that means FP6 is a salt. It's actually my zinc sulfate. Okay. To test with sodium hydroxide and ammonia, please make sure that you only use colors that are in this table. If you see purple color that's not in this table, repeat the experiment again. If you see purple, then just write down white. Okay? If you see black, you choose the one that's closest to black. I would take 23%. Okay? Do not write down black precipitation. There is no black precipitation in this table. Yes? Yes, this table will be this table, and this one will be given to you. Okay? Grading table will drop it. Okay, should be given to you. Okay, and then after you identify zinc, you write down the balance equation. I will not explain that to you. And this part require your organic knowledge. Okay? So I really don't remember if it will be an organic or an inorganic qualitative analysis. Okay, so but if you get this in an exam, that means you need to have a little bit knowledge of your organic chemistry, because ethanol is an aldehyde, propanol is a ketone, and you need to know the different observation for aldehyde and the different observation for ketone. Okay? Other things to remind you is decimal places. Be careful with your decimal places. If you don't know your decimal places, always follow the question. If the question starts with 2 decimal places, you follow the decimal place. Temperature is usually to 1 decimal place, either it ends with 0.0 or 0.5. I think I mentioned that in this note, yeah? Okay, so please read this notes. Calculation for error is also here. Okay. What else is in this notes? Heating. To practice calculation, my only advice for you is to try the past practical papers. Okay. Anything else? I will forward you the instructions they got. Don't forget to inform your subject tutors. If you will be missing their subject tomorrow, if you're missing their lesson tomorrow, please inform them earlier. Please go to the correct lab number. You may or may not be in the same lab as your friends. Please check the list again. It will be on the top floor. Yeah, guys. Okay. And do not be late. Check your seating plan, shift number, and lab number. Okay, and all the best to you all. Right? Okay, if you don't have any questions, then you can go now. Okay, fingers out, thank you. Also, please do not panic when you make a mistake. If you think that you don't want to waste time, just move on. Okay, do not repeat the same practical or the same questions like many times. 1 hour data collection, 1 hour calculation or anything post-lab. Okay? All right, you're welcome. Ayman, are you there? Oh, he left already. Okay.